Hello? Whoa.
I cannot see anybody.
Hello?
Hey, everybody.
Nope, it's too late. Too late, I don't even want it anymore. Welcome, everybody. Welcome to the last session of the last day of build. Is that true? They saved the best to last?
I don't think this is the last
We're
session.
We're not the last session?
No, I don't think so.
I was feeling bad about it there for a second because I was like, they either saved the best for last or they pushed all the crap to the end. I don't know.
I think that's what they did. They sent all the other stuff.
Who planned this conference and why do they hate us so much? Now, I know that you've seen a lot of PowerPoint so far, and I'm sure that you would like to see more PowerPoint, right? Yes?
Who wants to see
Who
more
wants
PowerPoint?
to see more PowerPoint? Can we get a show of hands?
No,
yeah,
you don't.
exactly. Slides with bullets, right? Who doesn't like to read slides?
No, you don't.
There was a journalist for the New York Times who wrote an article once called "We Have Met the Enemy, and His Name is PowerPoint." And we call that death by PowerPoint. So what we would like to do for you today is PowerPoint, but we're going to do it a little bit differently than you might have seen it before.
So, excuse me. So, my name is Cecil Phillip, and this is my buddy, Burke, Holland. And so what we actually want to do is kind of walk you through a journey that we went through in building an application in a very serverless way. So, you know, Burke and I are both cloud developer advocates at Microsoft. So essentially that means that we have the opportunity to go out and talk to a lot of folks, a lot of companies, a lot of startups, you know, students and things like that. And we talk to them about, well, how do you build serverless applications? And what are some of the things that we could do to make that an easier process for you, right? And so this journey that we're going to walk through today is essentially going to show you like one of the ways that, or one of the projects that we took on to kind of help people down that route.
That's right. So this session is called The Good, the Bad, and the Ugly of Serverless. I actually looked for the sound, like it's called the Western whistle. Everybody know what that is? Somebody do it
What's
for me.
that?
Oh, golly, that was bad.
Is that a thing? What is that?
Yeah, it's like. So I looked for that, got it, and then the presentation people were like, you can't use that, that's trademarked. I'm like, you've got to be kidding me. I just whistled it. So sorry, no whistle for you. You have to do your own whistle. But yes, this is the story of our journey. This is Cecil. My name is Burke. You can follow us on Twitter. And as Cecil said, we do work as cloud developer advocates here at Microsoft. And that puts us in an unusual position. Our job is to write about and talk to you about Azure, but that's not always easy to do.
It's not always easy to do because the thing is, like I'm sure a lot of you would realize, like so much stuff has gotten released just this week alone. And you know, to be honest with you, we haven't even heard about some of these things.
Yeah.
Like until like yesterday.
Right. We find out when you find out.
Right. Pretty much. So like, what does that mean? Right. Like as we're creating demos and samples and trying to tell you like what's the best way to do something, like we actually have to find time to actually use this stuff first, right? And so that becomes difficult. So what we decided to do was put together a project that would give us the opportunity to play with a lot of different tools and services and put them together into one package. And now we could talk to you about, well, what did it actually feel like to build an application, particularly in a serverless way?
Right, but we weren't sure exactly what to build. We wanted to build something, but we didn't want to just build another demo app that doesn't actually address any problems, right? We've all seen enough examples of wiring up a Northwind database and then have to go back and solve some actual problem that has nothing to do with the Northwind database. So what we wanted to do was not do that and address some of the hard problems that you have to solve when you build an application. So what we wanted was something that was useful, not just a demo, something that could actually be useful and be used. We wanted to build something that used Azure, and we wanted to do something that provided you with some real value and insight. In other words, we wanted to hit things or suggest things or try things that you might try when trying to do things the optimal way with the latest concepts and technology in Azure.
So it so happened one day Burke and I were in Vegas, because all good ideas come out when we're in Vegas.
That's right.
So we were in Vegas, and we're actually at a conference. And we noticed, well, like most presenters do, at the end you have the slide, and the slide has tons of different links. And everybody pulls their phones out, and everybody's taking pictures of these slides.
Right.
Right. Then you go home at some point, and then you go through those links, and you put them on your computer, and you take a look and see what those resources are. And so we thought, well, there has to be a better way to do this. Right? Like, because like what happens if you take that picture and, I don't know, something happens and the product changes, or things are a little bit different now. Like those slides, that information is stale now.
Right.
So we need to have a way that we can add updated information, and that you guys could just be able to consume that without having to be like, oh man, where do I have to search and dig around and try and find these things?
Exactly, and you probably have done this already at Build, where you got to the end of a conference and somebody's like, here's some resources, and you took your phone out and you took a picture, and then I always thought that was kind of crazy, like it's 2019 and that's our solution to that problem. It seems like it would be easier if we just had one link that we could give people, and then they could go type that in, and then that would bring up all the resources from the session. Now, every time I explain this idea to people, they're like, why don't you just write a blog post? I'm like, you could do that, but then I don't have an excuse to build an app, so stop offering me simple solutions to this very simple problem.
Yeah, exactly. So, well, as you can imagine, we went ahead and we built it, right? We went ahead and we put together a solution that we think would be able to solve that problem. And Burke going to show us a demo really quickly of the application we built. So the name of the website is called the URL list, and we're going to switch really quickly to the computer.
Hopefully. What do I have to do? Do I have to move my mouse?
You're on 3.
Yeah, I'm on 3. AV people, rescue me. We've got nothing. Oh, wait, you know what they said before? They were like, don't follow the numbers, follow the tape. That's super confusing. I feel like that's not my fault. Thank you.
So this is the website that we built for you. So essentially, in the URL list, what you do is you enter URLs at the bottom inside of the text box. And you can enter one or more URLs if you wanted to. Then at the top, you see there's a section that says URL. So you can actually put in like your custom address, like your vanity URL that you might want this to go to. Then on the right side, there's a description. You can add a description, like what is in this collection, what is this bundle. So let's say, for instance, like we had a collection of cool links, like Burke is saying. And this is something that you wanted to share with like your colleagues, your friends, your students, whatever the case is. And then now you can very quickly just go ahead and publish this. And now you just have a collection of links that you could share. Right? Super simple problem, not a lot of crazy stuff going on. Now, at the right-hand side, too, we also have the ability to log in, as you can imagine. So right now, we chose to go with Twitter, because we're always on Twitter and we're talking about stuff all the time. So we have the ability to authenticate with Twitter. And now that we can do that, when you see he clicks on that your face right there, you have the ability to go back and see all of the different collections that you've created. So I think this is really useful because, again, a lot of the times you have these collections of links. Sometimes you forget them, or maybe you might have put some links in some other things. Now you have like one place that you can kind of go through and have that. Now, we added some other little really cool features to it. So as you can see, like we can reorder those links that are in there. We actually have some interesting validation features that are happening. So there's client-side and server-side validation that's happening here. So you can see that name was taken, so we can't use that name. And then we also are doing URL validation. So you can only put in valid URLs into this. Right, and so again, this is the URL list. This is the application we built for you. Now we're going to talk to you a little bit about, so you've seen how it works. Like we're going to talk to you a little bit about how we built it and some of the tools and technologies that are behind it.
All right, so this is how this application is built. We worked in silos a little bit. So I worked on the front end, and Cecil worked on the API and the database.
Yep.
I'm a JavaScript developer, which means I know how to push pixels, but not much more than that. And Cecil built the APIs in C# and knew more about that. So I built the front end in Vue, and I also used TypeScript because I wanted to see what the integration with TypeScript in Vue would be like. And I wanted to build this application as if I was trying to build an application that would scale. So I wanted interfaces, and I wanted services, and all the types of things that you would create when you want to build a legitimate application.
And so I'm a big fan of C#. So I built my application in the backend using C# and Azure Functions. And then we're also using Cosmos DB to store some of that data. And specifically, we're using the SQL API inside of Cosmos. So we're just storing documents of stuff, which really gave us some flexibility when it comes to saving information and scaling.
Exactly. So that is the URL list, the application that we built. Now, this seems like it's a web app. And you're like, it's a web app. Cool stuff, buddy. I think I've seen one of those before. Who cares Why is this web app any different from any other web app that's ever been built?
Well, so this app is fundamentally different from anything that you've probably seen because of the fact that it's 100% serverless top to bottom. Right, so the front-end assets are being served in a serverless way, and the API is also being served in Azure Functions, which is, again, our serverless compute offering. So as we built this, we didn't have to worry about servers or provisioning or how much memory or RAM that we need. All we had to do was build our application, publish our code, and now we just left the cloud to go ahead and deal with that for us.
But Cecil, come on, man. I mean, isn't serverless just like a buzzword that you use to impress your friends?
Are you serious, dude?
Does it have any real meaning? Isn't serverless just something we say at parties so people will think we're smart? I don't know, maybe I'm going to the wrong kind of parties, but what does that even mean?
All right, so let's talk about exactly what serverless means. So everybody that you talk to has a different meaning about what it actually feels to be serverless. So we're going to give you like the Burke and Cecil definition of what serverless is. So for the first part, obviously, like, they are servers, but like the servers are abstracted. It means that we don't see the servers, we don't interact with them, we don't turn them on or off, we don't plug them in or out. Right? We're going to let the cloud provider deal with that for us. Secondly, too, we have the ability to pay for only the resources that we use. So that means that if something happens and there's a lot of load coming in, well, then we're going to pay for those types of things. But then if nothing happens and we don't have a lot of load, we don't have a lot of usage, then, well, we pay little to nothing at all. And so that's really flexible if you have a small business, if you have a startup, and you're really concerned about managing costs. You don't want to pre-provision all of these machines and servers and be paying for them every month consistently if you're really not going to be using all of those resources. And then another thing, too, is that we have the ability to have automatic scale, which I think is amazing for us. So again, like I mentioned before, as bandwidth increases up and down, as load increases up and down, we'll dynamically scale for you. So that means that they'll just automatically provision more servers to handle that additional load that's coming in. So for us, like, those are the three things that we consider to be serverless, right?
Absolutely, yes. And if you're a front-end developer, you may be familiar with this term Jamstack. You may have heard this. This is a horrible name for what's otherwise a very good idea, which is to have an application that is extremely low cost to use, extremely fast, and scales like a dream. That's what we're all after at the end of the day. The cloud is supposed to fulfill these promises. We think that the architecture that we've come up with delivers on that. That's why this app is fundamentally different. But if we pull back the lid on this thing for a second, we're going to talk about two of the underlying technologies that really make this possible. So we're going to talk about a couple of different Azure services, but we're really focusing on two here in this session. Azure Functions and Azure Storage is going to make a very strange appearance in a way that you might not assume that it could.
Yeah.
Cosmos DB is going to make an appearance, but not on the serverless front. But thanks for throwing that in there. I appreciate that.
So like we mentioned before, we used Azure Functions to build the API that's backing this website, this web application. And so how many of you are familiar with Azure Functions, by the way? Can I get a quick show of hands? We don't need to talk about this stuff anymore, man. Like, they already know
I know.
what's going on here.
That's it. Forget it. That's it. That's all we had.
So again, Azure Functions, as you guys already know, is our serverless compute offering. So you can write serverless applications using Java, JavaScript, Python, PowerShell. We wrote ours in .NET. But again, essentially, you have the ability to just write some code, publish it to the cloud, and again, you don't have to worry about, again, provisioning or any of that type of stuff, right? The cloud will just take care of it for you.
The other technology is Azure Storage. Azure Storage, its sole job is to deliver files everywhere in the world as fast as possible. Images, videos, data, and yes, websites as well. It is architected to do that and that only. And because of that, it is extremely good at delivering static assets. And the chances are, if you're building a single-page application with React, Vue, Angular, or whatever new JavaScript framework comes out next week that we're all going to have to relearn, if you're a JavaScript developer, that hits a little too close to home. That's why you didn't laugh. You were like, that's not funny, that's just true. This is the perfect place to put that, because at the end of the day, those really are just static assets.
Yeah. So now that we have a good understanding about what we consider to be serverless, why don't we start talking about what are some of the good things that we experienced as we were building this application?
So there's a lot of things that we thought were very good. Now, we're also a little biased here. Okay, so extend us a little bit of leeway there. We can't talk about all of those things, but we would like to talk about the things that we enjoyed the most about building this application and some of those services that we used.
So let's start off with the first one. We're going to talk about cost. Now, we don't have infinite resources in finance available to us. Like, we're just two broke cowboys, right?
Absolutely.
Just trying to get by.
Thank you for the analogy. I like it. Keep it going.
I think
the
people
Western thing
understand
going.
our analogy, right? But so essentially, like, there's a finite amount of resources that we have in terms of finance. And so what we need to do is be able to have a service that's going to allow us to, properly manage our costs.
Absolutely.
So it actually turns out that with serverless, like I mentioned before, we only pay for what we use. So if you use a lot of resources, then you're going to pay for that. And if you use a little bit of resources, then you only have to pay for a little bit of it. And it actually turns out that Azure Functions is actually very well priced, right? So when we talk about it, if you switch to the next one, so you'll see that Azure Functions only charges you like 20 cents per million requests per month, right? But what's actually interesting about this is that this is after your first set happens. So with Azure Functions, like your first initial ship, you get 1 million requests per month for free. I'm going to say that again so you guys let that sink in for a second. You have 1 million requests per month for free, right? So that's every month that resets. So that means that like if you're trying something out, if you're prototyping, if you're debugging something, then you can get started with a very generous offering of serverless compute. And then after that, you pay 20 cents per million executions per month. And then the next month, it goes back down to 0, and you start all over again.
Right, and if you don't use any of those executions, what do you pay? Nothing, exactly.
Sure.
And for storage, similar kind of deal. You're at 6.06 or 6 cents per gigabyte used. Our application not compressed is about 285 kilobytes.
Yeah.
And after that, you pay for that what we call ingress or egress in and out of storage, or the bandwidth, but you're at 8 cents per gig in and out, and you get a gig free every month. So all of this to show you that until you have somewhat of a significant load on your application, you're not paying anything at all, which is brilliant. It's just a safe way to develop, build, deploy applications without having to assume an upfront cost.
Yep.
So that's cost. We like cost.
Yep.
Cost is great. Get the money discussion out of the way. Of course, we want you to spend more money on Azure, but as developers, we also want you to be as successful as possible. We want to show you the best way to do things, and that's why we're showing you the inside secrets here.
All right, so what's next? What do we got?
The next one is speed. Now, when I talk about speed, I want to talk about speed in two different ways. The first one is speed of development, which is super important. And the second one is the actual speed of the application. So what I want to do now is run through a little bit of a demo with you from the code. So I'm going to go over to the front end, and this is the front end application right here. It's a Vue project. This is all of my source code. What I'm going to do now is I'm going to come over here to VS Code in the Azure Storage extension for VS Code. You can download this from the extensions marketplace. Then I'm going to right-click and create a new storage account, and we'll just call it the URList. Hopefully that's not already taken. Perfect.
Awesome.
Ooh, nice. Entry not found in cache. I'll tell you what, whenever this happens, quick VS Code tip, if this ever happens, you can just reload your window from the command palette here. Let it kick back into Azure for a second. Go ahead and close this. How many VS Code users out there? Lots? Yeah, it's so much fun. My favorite editor. All right, so let's do this again. Let's do the URL list. Perfect. Resource group, we'll create a new one. That's fine. West US, I think we're in the West. I don't know, I travel so much I forget where I am. Are we in the West? Where are we?
I think we're in West 2.
Okay. West 2. All right, perfect. So now this storage account's being created. So while that happens, what I want to do is perform a build of this application. Yes, it's 2019 and we have to build web applications. I'm sorry, that's the reality, but it is the reality. So I'm going to just do an npm run build here. And what this is going to do is it's going to take all of my TypeScript and all of my images, all of my CSS, and it's going to build it, minify it, and it's going to stick it into a folder up here called dist. You just saw it happen. Here it is right here. So this entire application condenses down to just these static files. And then what I want to do is I want to just configure my static website. So I'm going to select the storage account that we created here, which was called the URL list, I believe, right there.
Yep.
And then it wants to know, well, what file is the file that you want to serve? We're just going to serve the index file. And then it's going to ask us, well, what is the 404 page? In other words, if I can't find your file, what do you want me to do? And what we're going to tell Azure is just send them back to the index page. This is a JavaScript application, so it's going to handle all of the routing. And what actually happens in Azure Storage is if you send people to a route that doesn't exist, it goes back to the index page, and then we can handle that with JavaScript, and that allows us to handle all of our routes inside the index.html. So we'll just put index.html here. And you can see it's been enabled and configured, and now I'm going to right-click and deploy to static website, which I can barely see, but there it is. It'll ask me which one. We'll say this one, and now it's going to deploy. So you'll see it's going to upload these files. It's done. Now watch this. I'm going to click Browse the website. Boom, there it is. There's no startup time. There's no container to start. There's no node to get ready. There's nothing. It's just immediately available at a URL that I've never been to before. That is speed. That's how the internet should work. We love that about static sites. It's a brilliant thing.
That's awesome. So let's start talking about scale again. So like I mentioned before, we need to be the ability to be able to scale our serverless applications. But if we don't manage the server, well, how does that happen, right? When you think about how you do that today with virtual machines, I have to provision another virtual machine. I have to install my application. I have to set up networking and monitoring. I have to plug all that stuff together. And then what happens when you don't need that extra machine anymore? Right? You still have it. It's still plugged up. It's still eating power and resources, right? This is still something that you're technically having to pay for. But again, like we said before, with the cloud, we're just going to scale it for you automatically. So what I want to do, because I feel like I've been hammering this point into you for a long time, I want to show you a demo really quickly of how Azure Functions is going to scale. Now, I'm going to switch. Hopefully, I can switch this thing. Great. So what I'm showing you is my Application Insights dashboard. And so this is where one of the places that we could look at to monitor our function app. Now, you can see here I have stuff like incoming requests, and I can see outgoing requests and things of that nature. At the bottom here, you notice, I'm going to zoom in a little bit. You can see the amount of servers that are allocated for this particular application. So I have 4 servers here. If I scroll over to the side, you can see I only have like 1 or 2% CPU utilization. So these servers are pretty idle, right? Like they're not really doing a lot of work. So let's see if we can simulate some work. Now, here in my command line, I'm going to run a tool called Artillery. Is anybody familiar with Artillery? No? So Artillery is a load testing tool. So what I'm going to do from my machine, I'm going to simulate some load. Now, what I'm saying here is that I want to run Artillery, and I want to have 100 users generating 100 requests each. Right? 100 users generating 100 requests each. I'm going to send that load over to my web application.
It's 300 requests each, isn't it?
Oh, I'm sorry, 300.
300, yeah.
There you go.
So it's a non-trivial amount of load that we're now going to throw at this thing.
Right, right. So we're going to send a lot of requests over to our web app. So what I'm going to do now is I'm going to run Artillery here on my computer, and I'm going to switch back over to the Azure portal. And if you might have noticed already, we've already went from like 4 servers to 5 servers. And then as the load continues to come in, like it'll just continue to scale up the amount of servers that are needed. Again, I'm going to zoom in a little bit. You notice that this went up to 84, 80, 86, 80, right? But again, as load comes in, it just automatically adds servers for you. Now tell me, do you think if you had to provision a new virtual machine and set up your new application that you could have added another server in pretty much less than 2 or 3 seconds? Probably not, right? Like it takes time. But then that's the power of the cloud, right? The cloud will just help us provision those things really quickly so we can react to load that quickly.
Right. And as a developer, I feel like that's sort of the promise of the cloud that I was promised, at least, is that it would just scale up. And remember, when we talk about scale, we tend to think of scaling up, but scaling down is equally as important because you don't want to pay for what you're not using. You don't want to just leave the water on all the time. You want to turn it off when you're not using it and on when you are. And whoa!
That's a lot of servers.
That's a lot of servers. All right, so this is our scale. And again, we don't know anything about this, and we're not paying for instances here. We're just paying for executions. So that's scale. Scale is kind of a beautiful thing. Another thing that's very, very nice about the methodology that we chose was the local dev experience. So I would like to kick it over there, Cecil, to me. I'd like to point out that I am working on a PC, and Cecil's working on a Mac. So I built the front end in JavaScript on a PC. He built the API with C# on a Mac. What a time to be alive, right? Not what you were expecting at all. So what I'm going to do here is just sort of show you the way that this works. So we looked at the front end application here, which is written in Vue, and it's running right here. So I'm going to go ahead and run this in development mode or in the browser. Now, if you've done Angular, how many Angular devs in here? Couple hands. What about React? Some React folks? Couple folks. What about Vue? jQuery? Anybody? Any jQuery folks out there? It's okay. Yeah, right? Never forget. Hashtag never forget. All right, now, so what I want to do here is I'm going to pull up where I'm running here. And when you build a static application like this, it runs on a different port. It runs on a different development server.
Yep.
This is not like the days of MVC, where your front end and your back end are running the same project, right? We've moved on, and we're in a new frontier, but that new frontier comes with new problems. So I'm going to open this up here, and what I'm doing is running here, and then I've got Cecil's code running over here on this side. So I've got another Visual Studio Code instance, and I'm actually running the debugger. So what I can do here is put in a breakpoint on, let's just do get links. So this one right here, let me just come down a little bit on our get links, and I'm just going to drop a breakpoint right there. And then let's come over and open this up inside of our browser. Localhost, oh, there it went. So now, and then I'm going to hit the endpoint here. So let's look for cog services. And that should throw us into a breakpoint right here, right? And so as a front-end developer, I can load Cecil's code and run that locally along with my own, so that I can have an easier debugging experience. There are some serverless platforms where you don't have a local debugging experience. That's dumb. You shouldn't have to build code that you can't debug. That's crazy. So we really, really liked the local development experience of Azure Functions and storage, but not just on a PC.
It also works on a Mac, too. So I've just switched over to my computer. So I'm running Visual Studio Code just like Burke was, but instead I'm running it on Mac OS. And I'm going to show you that I have the same debugging experience that he did. So I'm going to attach to my Azure function. I'm going to hit the debug button. And now what it's going to do is it's going to spin up the Azure Functions runtime locally on my machine. And I think that's important for us to understand, right? The same runtime that's inside of the cloud, I'm running it locally. It's not a simulator or emulator. It is the same thing. And you know this thing is legit, right? Because we have like really cool ASCII art that's here, too. Now, I'm going to do very similar to what Burke did. I am going to have a breakpoint here that I'm going to hit. And now I'm going to switch over to this tool that I like to use called Postman. And if you're familiar with Postman, it's really just a tool that allows me to craft HTTP requests. So I actually have a collection here, a collection of predetermined requests, and I'm just going to select one. And now inside of here, I'm going to go ahead and make a request to my endpoint. So I'm going to hit send really quickly, and then there you go. So just like you saw before, I was able to hit my breakpoint locally on my machine. But again, more importantly, if you're a C# developer and you're familiar with Visual Studio or some of these other tools, you can see here that I have the ability to look up my local variables, right? I have the ability to check out my call stack. I have all the information that I need that's really important for me to develop locally in my machine. And it's no different from whether I run it on Windows or if I run it on a Mac, if he's writing JavaScript or if he's writing C#. We have that ability with Azure Functions on any platform.
Right. The cross-platform experience is just really, really nice. So that was the local dev experience, which was we really enjoyed that. That was great. And then the last one that I threw on here was CORS. People familiar here with CORS? CORS is cross-origin resource sharing. Now, if you're not a front-end developer, just know that in web development, if your back-end isn't running on the same URL and port that your front-end is running on, you can't talk to it. That's called a cross-domain violation. It's a security thing. You're not allowed to do it. It is the bane of every web developer's existence. When we run front-end applications like static apps, go ahead and switch it over there, Cecil, if you would.
Sure.
We are fundamentally in the middle of a cross-domain nightmare. We just are. My local host runs on port 8080, the backend runs on port 7071. They cannot talk to each other. The solution to this is something called cross-origin resource sharing, or what we call CORS for short. CORS, the way CORS works, is that we go to the server and we specify on the server clients that are allowed to talk to the server directly. And you can see with Azure Functions, CORS is just really easy to configure. You just go into your JSON file, you type CORS, and then you put the address or addresses that you want to be able to access this. And now I don't need any JSON-P, I don't need any shenanigans. I can just make those two things talk to each other, and there's no work to be done on my part. But how does it work in production?
Sure. So I'll show you really quickly what I had to do on my side, and I'll switch over to my machine. So now, here inside of the Azure portal, what we're looking at is my function app instance. What I'm going to do is head over to Platform Features. And then under the API section, you can see that we have an entry here for CORS. I'm going to select CORS, and then it opens up that blade on the right side. I'll zoom into this really quickly so y'all can see it properly. And so here, what you see is a list of all of the URLs, all of the domains that I want to say, hey, if you call my if you call us from using a JavaScript client, then this should be OK. So notice that we have our full domain, the urls.com. We have it with the www in front of it. But we also have local hosts in there, because we want to be able to call local hosts from our machines into the cloud using CORS, and we just want it to work. So again, we have the ability to just add as many of these as we want, and it makes our development experience really easy.
Right, so sort of the zero configuration there is what we're honing in on, that's something that just works out of the box. We thought that was really good. All right, let's stop beating around the bush. Let's get down to the nitty-gritty, as they say. I don't think anybody says that. All right, so see, these are some of the bad things that we ran into. The first one was authorization. Now,
well, I didn't think auth was so bad.
I thought it was really bad.
Really?
Yeah, nobody's ever built a login form and it was like, that was fun, let's do that again.
OK, you know what? I'm going to show you what I did.
All right.
How I got it taken care of. All right, so we're back inside of the Azure portal, and this is my function app. Now, for me to turn on authorization, all I had to do was under the networking section, there's an entry here for authentication and authorization. And this is how we get to App Service Auth. So if you're unfamiliar with App Service Auth, this is available for both Azure App Service as well as Azure Functions. But it's just a really easy way for you to add authentication to your application. So all I really did here was come and turn it on. And then if we scroll down to the bottom, you can see that I have these different providers that we can start connecting. So I have Azure Active Directory, I have Microsoft accounts, Facebook, Google, Twitter, all the usual suspects that you'd have when you're trying to authenticate. Now, we decided to go with Twitter. All I really had to do was click on this configure, and I'm going to enter my API key and API secret. Please don't copy these. And but now that's all it was, right? That's all I had to do. Now, from the Twitter perspective, if you've never built an application with Twitter before, essentially you'd go to developer.twitter.com, you'd create a new app, and then when I click on details, it'll just automatically give me these keys and secrets. So all I'm doing is I'm just copying and pasting information over. And now when I put it inside of my app, I'll just get prompted to log in with Twitter, and it'll just work.
Right. So Cecil messages me, and he says, OK, auth is done. And I'm like, the hell it is. All right, so go back over to number 3. So then I have a decision to make as a front-end developer, right? How do I do this? How do I implement what he just did? I don't know. There's a couple different ways that you could do this in a front-end app. You could pop open a new window, or what we call spawning a child process, a child window. But what we chose to do was to just open a modal. So one of the great things about Vue is that, I'm going to go ahead and log out so we can see this complete flow. But one of the great things about Vue is that there's a lot of pre-built components out there. So I just added a modal component to my project. Hoped to God there was not a virus in it. And then what I have to do is I have to call the function app.
Yeah.
And I'm going to show you here. If we just look in here and inspect, you can see the URL that we have to call. So it's right here. I'm going to zoom in a little bit. Hopefully we can see it. But what I'm doing is I'm calling the URL for the app. And see that .auth/login/Twitter? These are endpoints that just get lit up when you turn on authentication. They just show up. They're just there. And then the last thing you'll see is I'm passing in a post-login redirect URL. Basically, I'm saying, when you're done, come back to the application. Now, when they come back to the application, what I didn't understand is, so what? Right? What happens then? Well, I'm going to log in with Twitter. We're going to come back to the application. And all of a sudden, whenever I make a request to the function app, Cecil can just read that request and say, who did it come from? And I can actually ask his function and say, who am I? And the function will say, you're this person, based on the Twitter information. Because behind the scenes, there's a session. If we go here to application and to local storage, cookies rather, right here, right there, app service auth session. So we've got an auth cookie that we don't know anything about, right? I'm not even sure how it got there. It's just there. I don't know how it works. It just does. So that part was very cool. The reason why it was bad is because as a front-end developer, I just had no idea how to implement that, and I felt like I should have had to do more, right? So basically, after I call the auth URL, I just sort of sit back and let everything else just happen. So I spent some time on that. That was kind of rough for me, but not as rough for you.
Yeah, it really wasn't as rough for me. And actually, I forgot to show you something. I wanted to show you all exactly how you access this user inside of the functions code. So what I'm going to do is I'm going to switch back over to my computer really quickly. And so here inside of my functions application, I have a method here that's called getTwitterHandle. So the way that we get access to that is using the HTTP context, specifically in C#. And then it has this property called identities. Right? So what I'm doing is that I'm going to this claims identity. That's actually really hard to see. Let me zoom in really quickly. I'm going to look inside of this identity that's based off of the HTTP context. I'm going to be like, hey, do you have a user? Do you have somebody logged in using Twitter? And if it does, then I'm going to pull in that claims identity. But now I get access to things like the user ID and their email address and whatever other information that Twitter is surfacing from us, all from within our code. But again, as you can see here, there's really not a lot of code that's behind of here, right? Like, it's really super simple, but let's just pull that information out.
Right, but it was a little bit hard for me to wrap my head around and to understand exactly how that worked. So that's auth. If you want to talk to me about auth afterwards, I'd love to commiserate with someone about it. I'll be at the party tonight. I'll buy you a beer. And by me, I mean Satya.
All right, so what are we talking about next?
All right, so let's talk about hosting. So let me just say real quickly that when it came to hosting, we initially did not want to use static storage. And the reason is because when you use static storage, you don't get an IP address, okay? If you can't get an IP address, you cannot get a root domain or an apex domain, sometimes called a naked domain. We solved that problem. We'll show you how in a minute. But the reason why it was bad is because I had it was basically some static files that I put in a Docker container. Well, now I need a web server, so I added Nginx. Well, now I need a configuration file, so I spent days trying to make an Nginx configuration file. Now, I got all that to work, but none of that is value add, right? None of that is really what I want to do. I just want to serve an index file. It should not be that hard. So solving the IP address problem with static hosting was great because that didn't become a problem. But I did spend a significant amount of time configuring Docker containers, which is just overhead.
Yeah. All right, so let's talk about metrics for a little bit. Now, when you own your own machines, you have the ability to SSH into them or remote desktop into them. I could look at the log files. I could pull up the event traces because, again, you have full control over it. And like that's the good thing about owning your hardware. But if you don't own it anymore and it's sent out to the cloud, well, how do I get access to that information, right? How can I know how things are going, and how can I get information like health checks, or how can I know when bad things are happening inside of my app? So we need to have a way that we could be able to dig into our application and get good metrics and telemetry information. So it just so happens that we have a service called Azure Application Insights that allow us to do that. And so this really helps us solve this problem. Now, what you're looking at now on the screen is my instance of Azure Application Insights that's attached to our serverless application. Now, as you see here on the dashboard, I can see things like the fail requests and the server response time and the availability. Now, one of the things that I like to do is to head over to the Analytics tab. Now, here in the Analytics tab, I can dig down deep and get really detailed with the information that Azure Application Insights has been collecting for us. So in a second or two, when you see this left side load, you can see I have access to things like the page views and the requests and custom metrics and things of that nature. So for instance, if I wanted to click on something like requests, notice here that it's going to run a really quick query, and now I'm going to be able to dive down into all of the requests that have been coming into this application. Like I can open this down, and I could dig down and see things like where they're coming from and the city and
somebody came from Des Moines.
Do you know somebody from there?
I don't know anybody in Des Moines. Maybe somebody on the stream. No. Hi, Des Moines. Hi, okay. Sharon in Des Moines. I bet there's actually a Sharon in Des Moines watching the stream, and she's like, "Oh my gosh!" How do they know? We don't actually know.
So that was really cool, right? But one of the things I like to do with data sometimes too, sometimes you want to visualize and see what's happening. So inside of this area here, we have the ability to generate charts and graphs, which I think is really cool. So what I did was I just ran a query, and it just generated this pie chart for me. And so this particular query is showing me like the endpoints that people are going to. So like this big blue area, everybody's going to like the home page, as you can imagine, right? And then you can see like some of the other endpoints that people are going to.
Right.
Now, what I've been doing here, and you may or may not have noticed, is I've been writing queries using a language called Custo. Like Custo is a language that powers application insights, Azure Log Analytics, and tons of Azure services. But essentially, it gives us a really cool way to really drive down and dig down into our application data. But you might say, well, what if you don't want to write queries? What if you just kind of want to just see and surface
What if I
information?
don't know Custo and I'm scared of data?
What if you don't know Custo? Are you scared of data?
I'm very scared of data.
Oh my God, dude. All right, so one of the things that we could do that I think is really cool is we can just generate custom dashboards here from Application Insights. So here on the overview page, I'm gonna click on this thing that says Application Dashboard. And now what it's gonna do is generate a dashboard for me on my Azure portal homepage. Now if you take a look here, you can see I have information about the usage of my application, the reliability, the responsiveness. And then there's tons of great data that's inside of here that we could take a look at, like the average process input I/O and things of that nature. What's really cool about this is, like, imagine like you're inside of your team room at work, and then you just stick this up on a big old monitor in the corner. And as you're working through bugs, as you're working on performance problems, as you're cranking out code, you can take a look at this live and see how exactly it's affecting your application. And you can see exactly how it's performing. So if something happens, you have the ability to see it right then and there and react to it, which I think is really cool.
Yeah, and as a front-end developer, this was interesting to me because usually as front-end developers, like if we want analytics, we just throw Google Analytics on there and we're like done with it, right? That's it. But in this case, we're using Application Insights, which provides us the same level of analytics, but now we're looking at the application together. So we have the API portion and the front-end portion, and it's all there in the same dashboard. That's what we really want to see. What's the health of the whole application, not the different pieces?
Right.
All right. So let's talk about the ugly stuff.
We're gonna get in trouble.
I wish we didn't have to do this.
Oh my God. Okay, let's do it.
This
Let's
was
go.
bad. Whose idea was this? All right, so there were a lot of things that we did, especially towards the end, like 2 weeks out from build, in a state of panic, that were bad. Just frankly, not any fun at all, and extremely emotional at times as well. This is true of any application you build. There is no service, no provider that is going to mitigate the last 20% of your application, right? The first 80% takes a month, and the last 20% takes the rest of the year, the last 11 months. So this is the last 20% of our application.
Okay, so let's start off with talking about proxies. Now, when we built our application, like remember earlier Burke was talking about we were running locally, and we had our functions endpoint, and we also had our front-end assets endpoint, right? That was serving our static assets. But it actually turns out that when we deploy our application, now they're running on 2 different ports and 2 different servers. Right? This is where the asset, the JavaScript and stuff is coming from, and this is where our API is living. So what we actually want to do was just have like a unified experience, right? And so we didn't want to have to deal with cores and like all this extra stuff, because that just kind of felt like extra work. So we decided to look into something like Azure Proxies. Everybody of you familiar with Azure Proxies and how that kind of works? Okay, so with Proxies, essentially it allows you to define special routes inside of your function app. So you could say like if a request comes in at a certain port, I want you to direct it to a certain asset, right? So essentially, like I could start directing traffic to a certain place. Now, the thing why proxies didn't really work for us was because, well, we had this API, and we had a lot of HTTP triggers. And our HTTP triggers had a lot of custom routes. So it turned out that our custom routes and the proxies kind of started to step on each other's feet a little bit. And so we had to figure out something better. So we looked at tons of other options, like we looked at Traffic Manager, we looked at Azure DNS, we looked at tons of other services.
Right, we didn't really know what to do. And a lot of it was just not knowing how do we glue these 2 things together so they look like they're running into the same URL.
Right, because again, so we had a problem to solve, and we had to figure out what was going to be the best tool for us to solve it. So in our case, we ended up going to a tool called Azure Front Door. And if you've ever heard about Azure Front Door, that's one of our new services. And essentially, it allows us to define like a pool of servers or resources in the background, but it essentially directs us to the best server to handle that request for us. So what we can do now is we can define routes inside of Azure Front Door. So I can say, well, when a request comes with a certain URL path, send it to one place, and if not, send it to another place. So let's actually head over to Burke's machine really quick.
You want to talk through it? Sure.
And we're going to see what that looks like really quickly. Great. So what we're looking at here is that designer for Azure Front Door. So what you can see is that we can define our front-end hosts. So at the bottom, you can notice we have the urls.com, right? So we know that every time a request comes in with a host header that has that, it's going to come into our Azure Front Door, and it's going to be able to work with it. Then the next thing we had to do is define backend pools. So the backend pools are essentially what are the servers that are handling our requests. So notice there's one for the front end, because again, our front end assets are being served from one place, and there's another one from the back end. Right, and the back end is also being served from a completely different place.
Right, so our front end is the static storage, and the back end is the Azure Functions.
Right. Then, so we defined our servers, and then the last thing that we had to do was we had to define some routes. So the last part is the routing rules. So now, if you look at the routing rules for our backend server, which one is this?
That was front end.
I'm sorry. So if you look at the ones for our front end server, you can see that anything that comes in on that default slash, we're going to direct that over to blob storage, because that's where we're hosting our static assets, right? And now if we take a look at the other one that's in the backend for our API, anything that comes with /API, we're going to direct that over to our Azure Functions backend in the back, right? So Azure Front Door is going to be able to handle a lot of that other stuff for us. Another thing that I think is really cool about Azure Front Door is that it gave us an HTTPS certificate for free.
Yeah, it gives you
it
just sets up a cert for you for your www domain automatically.
Which is cool.
Happens.
So I think we actually showed that in the first one. If we take a look at the front-end host and you click on the urls.com, is it in that one? Right, so you see we have the option, so we can use our own certificate if we wanted to, or we could just use the certificate that's provided by Azure Front Door. And we had a lot of issues going back and forth with certificates, so I was very happy to just take the one that they gave us.
Now, Azure Front Door gives you a few other very nice things, including CDN-like functionality. So it caches your application at the edge, giving you even more speed. And because we're using static assets, we definitely want that. The other thing that it gives you is health checks. So it will actually check to see if your application goes down and report on that. And it's also consumption-based, which qualifies it in a way to be classified with serverless. In other words, you're paying by the request, and you get a certain amount of those as well. So that was Azure Front Door. We spent a solid amount of time, because this tool is new and with the help of the PM, trying to figure out the right way to set up and glue all these pieces together. If you're interested in talking more about this, we'd like to do that. We're also going to publish some blog posts on how we set this up, because really the meat of the magic is in that service there.
So I know you also had some issues with DNS too, right? Do you want to talk about those?
Yeah, so here's where we get into some really esoteric stuff. So here's the problem with DNS. I don't know anything about it. So I went to Namecheap, and I bought a domain name, and you're supposed to go in, and the fundamental problem that we have is that you need to have an IP address to create what's called an A record. So in other words, the urls.com, no www, just the urls.com. Well, Azure Front Door does not give you an IP address. What it gives you is this domain right here, the urls.azurefd.net. Likewise, static sites don't give you an IP address, right? So as a developer, you're sort of stuck. Well, what do? I can't just tell people, hey, don't go to the urls.com. That doesn't work. Like, that's not an answer. I need an answer. So what we ended up doing was we used Cloudflare. Now, Cloudflare is a different service provider. They do have a pretty good free tier. Oh, bump it over to my...
Your machine?
Yeah, my machine there.
Switching over right now.
Perfect. So this is our Cloudflare setup, and we're doing something very simple here. Here's what we're doing. I've defined www to go to the urls.azurefrontdoor.net. Works fine, okay? That's called a CNAME. Does everybody know what a CNAME is? Me either. I don't know what it is either. I just know you're supposed to have one. I'm just being honest. If you want to talk about DNS, talk to someone else. I'm not the person. All right, so the other thing that we needed was, because we couldn't have an A record, which is the apex record, but a Cloudflare allows you to create a CNAME that you can also point at a URL, not an IP address. So you can see I've created a CNAME for the urls.com. Now, this will break, because what what Cloudflare actually does is it pings that URL and then returns the IP address. But the IP address is just the load balancer of front door. And front door is like, I don't know what you want, right? You asked for an IP address. There's tons of sites back here. You didn't say which one you wanted. So what we did was we just created a simple page redirect. So if we go over here to page rules, we just come down here. We've got one page rule. And all I'm doing is saying, hey, if someone tries to go to the urls.com, just send them to www.theurls.com. This works really, really well. Really well. This is a very good solution when you don't have access to an IP address. Now, some of you may have just sat through the last 2 minutes and gone, what are you talking about? But if you've ever had this issue where you're trying to get an Apex domain and you don't have an IP address, it is a hair-pulling experience. I am living proof.
You sure you want to say that?
Yeah, I don't know. All right, switch us back over. All right, let's do one more on the ugly. I want to address what's a bit of the elephant in the room, which is something called cold start. So I don't want to dance around any issues here in front of you. When you're using Azure Functions, there is something called cold start. Your application is not always in memory. Sometimes it's on disk. If nobody has asked for your function in 15 minutes, then it gets put back on disk. The next person who asks for it, it gets loaded into memory. Well, for that person, there's something called cold start. It's about 3 to 5 seconds, depending on when you hit it. And if we go to the URL list, if you were the first person there, and it hasn't been hit in a while, when you go there, you saw that little green bar flash across the top, but it'll sit there for about 5 seconds. And what that is the API, it's just waiting for a response. So this is a bit of a problem. We want the application to be snappy. So there's a couple of options here to fix this. One of them is to use the new premium functions offering that was just announced. If you have the money to spend on those resources, this is a fantastic option. Your app is always hot, always responsive. The other thing is, I'm just going to be completely honest and tell you that Azure Front Door does health checks. And that means that it hits our backend API every minute. And when it hits the API every minute, it stays hot in Azure Functions because we're hitting it every minute. Now, we are paying for that, but I did the math, and it's like 0.00016 cents a day, which I feel like I can cover.
But if you wanted to, you can configure it, right?
You can configure it up to 255, but you should just know that that's the way that Azure Front Door works. So the health checks actually ends up being a benefit because your API is always hot, and you're still basically paying nothing. So I hope there's no sales folks in the room. They hate me now.
Oh, man. I tell you, we're going to get in trouble.
I know.
All right, so let's recap some of the things that we spoke about, right? We know that we talked about the good things, which are cost was good. We thought cost was really good. The speed, scale, the local development experience, both on Windows and Mac, we thought were really good. But then we also had some issues, right? Auth was the issue. Cores were, caused an issue. DNS and things like that. But we were able to work with it, trying to figure out, well, how can we best solve these problems by looking at different tools and different options. Now, we spoke about this really quickly in just about an hour. But believe me when I tell you, it took us a really long time to solve some of these things. Because it's trial and error, right? You have to spend the time playing around with the service and trying to figure out, well, what's going to be the best option to solve the problem that you have.
Absolutely. So let's review the stack real quick. Technology-wise, we believe that this is one of the best ways that you can run an application like this on Azure, what we'll call a Jamstack application. Azure Front Door for all your routes and your proxies, handling your domains. Behind that, Azure Storage, which has your site. Behind that, your API, which is running in Azure Functions. And then behind that, some sort of data store. We've chosen Cosmos DB. Most people already have a database. I meet very few developers who are like, I don't have a database. People usually have a database that they want to already tie into.
Exactly. So do we have something for them?
We do.
What do we have? What do you got?
So today, this is the first time we get to use this application. We have so many resources that we want to give you. But instead of doing that, we're just going to give you a URL to go to. So you can go to the urls.com/build2019. And in fact, I will go there with you so you can check this out.
Yeah, let's see what we got.
And we will show you the things that we've left here for you. Let's go build 2019. And here's all the things that we have. We have the GitHub repo. You can get all the code. You want to see how we built the View app? You can get that. Want to see the Function app? It's all available for you to see. It's documented as well. We're releasing this today. We've got some links for some tutorials we think you might like. We've got some links that the Functions team said, please put these links in your presentation. So here we are. We love you, Functions folks. We have Cecil and myself down here on Twitter. We're obsessed with fake points, so we'd appreciate it if you'd follow us there. And y'all, I made you some wallpapers just for this session. Yes. So you can send your JavaScript or your C# to the cloud. I'm not going to judge you, whichever one is your favorite.
That's like the best swag that I've seen here.
I know, that's it. We don't have any socks for you, but we do have wallpapers.
Sure. So thank you all so much. I definitely would love for you all to check out the urls.com, take a look at the code, take a look at what we've created. Let us know what you think. You know, we welcome pull requests and issues and all of that type of stuff. So again, we definitely look forward to you trying it out, and thank you all so much for coming out.
Yes, and one more thing. Please rate our session. Please. Send in your feedback, unless you didn't like it, in which case it's okay. Nobody needs to rate the session. Nobody looks at it anyway. Thank you so much for coming.